In this video, I'll be going through one complete past year physics IBE assessment paper. So it'll include criterion A, B, C, D, the entire paper. For question 1, mammals need to keep their body temperature within a given range, a concept called thermoregulation. This question is about the physics of heat transfer used in thermoregulation. So select which of these animals is better adapted to living in cold conditions. I'm sure without even having to really look at the descriptions, we can tell the answer is the polar bear, mostly because of its long and thick fur that allows it to survive in the cold. So the answer is option C. Second question, reindeers have fur with hollow hairs. Outline how this feature enables reindeers to keep warm in cold weather. So they give us a picture of the reindeer, but also an idea of what hollow hairs would look like through the illustration of toilet paper. So fur with hollow hairs allows more air to be trapped within the hair. So this air will be warmed by the heat from the reindeer, acting as a barrier from the cold air outside. So this prevents the cold air from reaching into the reindeer skin. And also because air is a poor conductor of heat, so it prevents the reindeer's heat from leaving its body. Question 3, the Arctic fox is another animal adapted to living in cold conditions, while its distant cousin, the fennec fox, has evolved to live in a hotter desert environment. Outline how the color of the Arctic fox's fur and the size of the fennec fox's ears helped with thermoregulation. You should use scientific language in your answer. So we can see that we focus on the color for the Arctic fox's fur. So the color is white, which means that it has no pigment. So due to this, the hair would be hollow. So it'll also allow more air, a poor conductor of heat, to be trapped within, preventing cold air from coming into contact with the fox's skin. And the fennec fox, on the other hand, has ears with a large surface area, as you can see in the photo. So it allows heat to be released from its body through the ears instead of having to sacrifice water through evaporation. So actually, for this few set of questions, if you take biology as a subject as well, it'll probably be easier to answer these questions. And question 4, one method of thermoregulation in dogs is evaporation from their wet tongue and nose. Explain how the process of evaporation will lead to a cooling effect in dogs. So this is the concept of evaporation. We can see from the photo that dogs stick out their tongues when they pant. So during this panting, water molecules from the surface of the wet tongue and nose would escape as gas molecules. So this takes the energy of the layer of water molecules below it, leaving a cooler surface on the dog's tongue and nose. So this cools down blood vessels, keeping the brain from overheating, which also allows blood with low temperature to flow throughout the body. And basically, the large surface area of the tongue and the rapid flow of air through the nose allows maximized cooling through evaporation. And moving on to the next set of questions. Hill climbing is a motor sport where drivers compete against each other to drive up a hill in the fastest time. A major event in the sport is the Pikes Peak event held in the USA. So the length of the course is 20 kilometers. It starts from here and ends here. So the first question, they give us a Sankey diagram. It says that below it represents the energy changes associated with a car engine. Label the energy forms in the diagram. So in the actual software, they gave you examples of energies and you fill in the places. So the car engine itself, it starts with chemical energy, but most of this energy is lost as heat. So 70% are heat losses, and there's 25% of useful energy output, as well as frictional losses. A Sankey diagram is quite self-explanatory. The size and thickness of the arrow determines the magnitude of the energy, which makes it easy to sort of determine where everything should go. Question 2, the event starts at an altitude of 2,860 meters and ends at an altitude of 4,300 meters. A car competing in the 1988 race had a mass of 880 kilograms. Calculate the gain in gravitational potential energy So they tell us we should assume that it's 10 Newton per kg. So the formula for gravitational potential energy is mgh. But since they want the change in gravitational potential energy, we minus the gravitational potential energy from above with the one below. So it's basically the same formula, except that because the mass and the gravitational field strength will remain the same, but the height at which we're focusing on is different, which will give us the gain in gravitational potential energy due to the gain in the increase in height. Question 3, a lighter car traveling the same route gained 8.8 megajoules, gained 8.8 megajoules in 546 seconds. Calculate the power of this car. So the formula to calculate power is energy over time. So the energy they mentioned here, we can just change it to joules, which is 8.8 times 10 to the power of 6 joules, and 546 seconds. In a physics exam, you have to be very careful with the units. You'll have to change it back to the SI units. They often love to play with that, so you have to be careful with that. Seconds and joules are the units you should be using in this situation. So power of the car, 16,000 watts. The next question. This question is about light waves in space. When we look up at the night sky, many bright objects are visible. Select whether each object emits its own light or reflects light. So they give us the options star, moon, planet, and satellite. As we know, the only object that emits its own light is a star, while the rest reflect the light from the star to make it appear as if they have light on their own. So emits, reflects, reflects, reflects. Some satellites are always at the same point above the surface of the Earth. These are known as geostationary satellites. Statewide, these satellites appear to be stationary. So these satellites are launched in a way that allows an orbit parallel to the Earth's equator, and it travels in the same direction as the rotation of the Earth with the same period of 24 hours. So it makes it appear to us that these satellites are stationary in the sky. Satellite phones allow people to communicate in remote areas. State one additional application of geostationary satellites. They could possibly be used as weather satellites to determine weather forecasts. And geostationary orbit is approximately 36,000 kilometers above the surface of the Earth. Light travels at 3 times 10 to the power of 8 meters per second. For someone using a satellite phone to communicate with a friend, calculate the minimum time delay between sending a message and it being received back on Earth. So the orbit is 36,000 kilometers, but the distance we want to consider is the distance to send the message and to receive it back. So we have to multiply it by 2. And the speed of light, 3 times 10 to the power of 8. So the formula to calculate the minimum time delay is distance over speed. Distance over speed, which will get you your time, 0.24 seconds, which is the minimum time delay. And the Hubble Space Telescope is a satellite currently orbiting the Earth. Astronomers can use the light gathered by the telescope to observe that distant galaxies are moving away from each other. Outline how this observation provides evidence for the origin of the universe. So this describes the redshift of galaxies, providing evidence that the universe is like expanding from a central spot. So this goes back to the Big Bang theory, which states that when a bang occurs, all matter will move away from the point of origin. Question 4, we're going to the criterion BC section. So all the criterion A questions are over. Between 1889 and 2019, the kilogram was defined by the mass of a block of metal known as the International Prototype of the Kilogram. In 2019, scientists decided that a new way to define the mass of a kilogram was needed. The Kibble balance uses the force of an electromagnetic field produced by a current in a wire to balance the weight of an object and therefore calculate its mass. It is possible to investigate the same effect in our school classroom. So the exam gives us a diagram of the Kibble balance, the electromagnet, and a 1 kg mass here. So an electric current through the electromagnet is increased until its pole makes the two sides balance. Your teacher has asked you to investigate the strength of an electromagnet that you can build in your school laboratory. This consists of a circuit with a coil of wire wrapped around an iron rod. When a current flows through the wire, a magnetic field is generated. Your teacher tells you that there are three factors that affect the strength of the magnetic field. This includes the current flowing through the wire, the number of turns in the coil of wire, and the distance between the wires. You first decided to investigate how the current flowing through the electromagnet affects the strength of the electromagnet using the method described in the video. So when it comes to MYP science criterion BC questions, usually all of them are connected. So the main concept will be about this electromagnet, but we'll be exploring most likely different independent variables throughout the different sections of the questions. So it's sort of a continuation because IB likes to focus on those real life applications. And actually, usually most of the time, you don't really have to worry about not understanding the experimental setup or the scientific theory behind it. If it's something you really would not know, the exam will provide you with a diagram or a video to explain how variables affect each other, or at least how the experiment is like. So I'll be showing the video that was given for this specific situation. So as you can see in the video, they not only show you a real life setup and also a diagram of the experiment, they also give you the scientific reasoning behind any effect that uh, current would have on the electromagnet, because that's the first set of questions they give you. So you can actually gain a lot of information from these types of videos that the examination gives you. So you should pay attention to that. The first question would be to state the research question this experiment could investigate. A research question is simply just mentioning the relationship between the independent and dependent variable, as in the variable that you change and the variable that you measure. So you can always start the sentence with what is the relationship between, and you mention the independent variable and the dependent variable. So they already mentioned the independent variable is the current flowing through the electromagnet, and the dependent variable is the strength of the electromagnet using the method described. So the method that this experiment focuses on is the number of paper clips that can be held by the electromagnet. That is how the strength of the electromagnet is determined. So below is a list of variables that are important in this experiment. Select the description that best describes each. So they ask you to determine whether it's an independent, dependent, or a constant variable. There's only one dependent and one independent. So the moment you identify what changes and what is measured, the rest are all constant. So we know that current is the independent variable, and we know that the total weight of paper clips supported by the electromagnet is the dependent variable. The rest must all be constant variables. Using the information contained in the video and your knowledge of electromagnets, formulate a testable hypothesis that could test your research from part 4.1. So how you write the hypothesis, they already give you the format. So if the independent variable, in this case current, changes like so, then the dependent variable will change like so, because you provide a scientific reasoning. In this case, it's quite easy because the video pretty much gives you that scientific reasoning. So if the current flowing through the electromagnet increases, you can say decreases as well, but you have to change the next response accordingly. Then the number of paper clips supported by the electromagnet will increase because a higher current flowing through the electromagnet allows a stronger magnetic field to be generated. So as the field is stronger, a stronger force of attraction can be exerted on magnetic materials, which includes paper clips. So as long as the electromagnetic force exerted is greater than the total weight of the paper clips will still remain attached. So when the electromagnetic force increases, a larger number of paper clips can be supported. In the laboratory, you have a range of equipment available. Select one piece of equipment that you would need and state how it will be used in the investigation. Whenever they give a question like this, by equipment, they always mean something that would normally be to either change the independent variable or measure the dependent variable. So anything to keep any of the constant variables constant is not the equipment that they're looking for. So in this case, it would be D, which is an ammeter, which can be used to measure the current flowing through the electromagnet, which is our independent variable. So it's needed to accurately vary the independent variable. Question 5. The images below show 3 options for collecting data. Select the most appropriate data set. Justify your choice. So I mentioned this in the science video. What we should always look out for is how many trials are there. There should be at least 3 trials. How many increments in the independent variables are there? There should be at least 5. And they should be increasing at constant intervals. So we can see that A records 6 trials, that's good, but there's only 3 increments for the independent variable, and they're not regular increments as well. And C only has 1 trial, which already makes it out of the picture. So it's only B that's possible because it allows at least 3 trials to be conducted, which you can explain allows random errors to be minimized through the calculation of an average. And there are also 6 increments with regular intervals, allowing an accurate trend between the independent and dependent variable to be obtained. Question 5, you can see it's sort of a continuation of this entire setup. 2 different groups of students in your class choose to investigate a different variable. So we're still dealing with the same dependent variable, we're just changing the independent variable. They both investigate whether the strength of the electromagnet, so you still determine it by the number of paper clips that are attracted, by the spacing of the turns wrapped around the iron rod. So now current is kept constant. They say that the current is kept constant at 2 ampere. So it's the spacing of the turns wrapped around the iron rod, that's the independent variable that will be changed. So there are 2 groups of students. The first group uses larger paper clips, each with a weight of 0.2 Newton, to determine the weight supported by the electromagnet. The data from their first set of trials are collected into a tablet. So the first thing you should notice is that whenever they mention any piece of specific information, it'll most likely be used somewhere else later on in a question. You'll be able to see how both of these pieces of information will be used in other questions following. So this is the tablet which is used. Present the data from the tablet in a table. When they say this, they just want the direct raw data. So you're not supposed to do any calculations. It's supposed to be exactly what you measure directly. So it's not processed data, it's just the raw data. So from this table, they'll expect you to determine what the independent variable and the dependent variable. So you'll have to label the titles for each column, and you have to make sure to include the units, except for this number of paper clips, there's no units. And it's good if you can go in ascending order, 1 to 6. So if we look at the length of coil, we look at the one for 1 length of coil, this is 1 cm, and the number of paper clips supported are 6. Then if we increase it to go to 2, 3, and then increase it to 3, 2, and you can see the rest, no matter what the length of the coil is, the number of paper clips supported are always 1. And the second question, calculate the number of turns per centimeter and the total paper clip weight for each measurement. Present this process data in a second table. So this is the table where they actually want you to do calculations and include process data. So number of turns per centimeter, they already give you the first title, and total paper clip weight supported. So you'll have to include the unit here. Here there's no units. So let's go back to this one where the length of coil is 1. So we can see here the length is 1 cm, but then the number of turns of the coil is 6. So number of turns per cm, which is already 1 cm, is 6. But if we go, for example, if we were to go for the one where the length is 2, so the length is 2 and the number of turns of coil is 6, which is constant for all, you'll have to ensure that this goes to 1, so you divide by 2. And hence you divide this by 2 as well, you get 3. So it's just simple ratio. And if you do that for all of the values, you'll get the different number of turns per cm. And now they're asking for the total paperclip weight supported. So this is where this piece of information previously mentioned is useful. They mentioned that each paperclip weighs 0.2 newtons. So you multiply the number of paperclips supported by 0.2. For example, 6 times 0.2 is 1.2 newton, and so forth. That's how you can complete this table. Question 3, the first group used large paper clips in their experiment. The second group uses smaller pins, each with a weight of 0.01 newton. Justify why the second group of students who uses smaller pins will produce a better set of data. So if we were to take notice of the data before, we can see that even when the number of turns per cm changed towards the end, this set of data had the number of paper clips supported were all the same, even when the length of the coil was still increasing, even when the number of the turns per cm was still decreasing, which shows that the paperclip weight was perhaps too large to show any significant difference. So even when the number of turns per cm were varied, the total paperclip weight supported remained the same, which means that the difference in the force that could be exerted by 1.5, 1.2, and 1 number of turns per cm was very small. So this difference could not be properly shown through the usage of larger paper clips with a larger weight. So the second group of students that use smaller pins with a smaller weight would allow more accurate and reliable data to be obtained. The relationship given from this experiment was this, which means that the weight supported is directly proportional to the current multiplied by the number of turns per cm. This is the part where you have to remember that the current is constant, so the weight supported is only affected by the number of turns per cm. So the second group produces the following graph of their results. The graph showing the weight of pins held by a magnet against the turn spacing. So we can generally see from the graph that we have a directly proportional relationship because it cuts through the origin and it shows a straight line graph, which is generally indicative of a directly proportional relationship. So also one thing to take notice of is that in this situation, the gradient, which is constant, is the current because of this that they mentioned previously. You can take this as sort of y equals to mx plus c would be 0. So we can just consider as y equals to mx. So m would be the gradient, which is the current. X would be what we change, which is the number of turns per centimeter. And y is the weight of pins supported. So use the graph in part 5.4 to explain if the data supports the relationship. So as mentioned, the data does support the relationship because the relationship states that the weight supported is directly proportional to the current multiplied by the number of turns per centimeter. So based on the graph, we can see that as the number of turns per centimeter increases, the weight of the pins supported increases as well. This is true because the turns be more packed in the same space, allowing a stronger magnetic field to be produced by the electromagnet, which allows more pins to be supported. So we support the idea that it's directly proportional. We should also mention that the best line fit is a straight line that passes through the origin. And we can also mention that the current stays constant at 2 ampere, so it does not change. When it comes to explaining whether a graph supports the relationship, it doesn't just mean because the independent variable increases, the dependent variable increases as well. So it's directly proportional. Most of the time, you'll also have to give a scientific reasoning, which if you don't know whether you should or not, you can take a look at the number of marks. You can see they give you 4 marks. So by that, you should already be able to determine that they want an extensive answer. The independent variable in this experiment was number of turns per centimeter. If the independent variable was changed to current, so we're going back to current, predict the shape and the gradient of a graph drawn from the new data. Recall that the gradient of the graph shown before was the current itself. So now if the current were to be changed and the number of turns per cm were to be constant, the relationship between the independent and dependent variable will still be proportional, because in this situation, it would just be that instead of the number of turns per centimeter being the x value, it would be the current. And the m value would now be the number of turns per centimeter. It would act as a gradient. So the line would have the same shape. However, the gradient would now become the number of turns per centimeter instead of the current. Question 6. We normally expect liquids to flow downwards through a tube. However, if the diameter of the tube is small enough, the liquid will rise up through the tube. This process is known as the capillary action. This is one of the mechanisms by which the liquid flows up through plant stems and tree trunks. So there's a video shown, but this picture pretty much just depicts whatever the video shows. It shows how smaller diameter allows liquid to travel up to a greater height. A student decides to perform an experiment to investigate capillary action. After some research, they discover that the height to which the water level has risen above the liquid surface is determined by the following equation. So height above the liquid surface equals the capillary constant multiplied by 1 over the diameter. So the capillary constant is the constant of proportionality, which also means that it's the gradient. By chance, the height above the liquid surface were to be graphed against 1 over the diameter, the capillary constant would be the gradient. And we can also see from this that the height above the liquid surface would hence be proportional to 1 over the diameter, purely because the capillary constant is constant. From this, the student makes the following prediction. As the diameter of the tube increases, the height that the water travels up the tube will increase, because we should take note that the height is proportional to 1 over the diameter, which means it's inversely proportional to the diameter itself. So if a graph of height against 1 over diameter is plotted, it will show the relationship is proportional. So here, the e-assessment software actually allows you to sort of move the ruler to determine the diameter and also the height, but I just took photos to show what it's like. This is diameter A for the first tube, B for the second tube, C for the third tube, D the fourth tube, E the fifth tube, and also the height of the water for A, B, C, D, and finally E. So this is just what they allow you to move the ruler in the interface, allowing you to measure it yourself. But they actually record a lot of the data for you already. So they say measure the height of the water in the tube and complete the table. So they want us to complete it for C. So let's take a look at C. What they want us to determine is the diameter and the height of the water. So this is a value we have to calculate. So let's go back to C. Start with the height. From here, the ruler, if we were to look at over here, it would be around 12 mm. And if we go back to where they show the diameter, it would be approximately slightly less than 2.5. We can say it's around 2.4 mm. So completing the table, we get 2.4 as diameter. 1 divided by 2.4, we get 0.42. And height of the water, 12. Question 2, plot your measured value on the graph below and draw a line of best fit. You should add labels to your axes. So this is the graph that they provided, and you were instructed to plot the point that you determined and then draw the best fit line, in which the plot is pointed over here, and this is the best fit line. So the label is, the x-axis would be 1 over the diameter, in which this would be the unit. You have to include the unit whenever you label the axes. And the height of the water, which is in mm. Calculate the capillary constant from the graph. As mentioned before, this is the gradient of the graph. So you take one of the points. I took the point where this is the point that I took. Oh, no, wait. Yeah, this is the point that I took. 19 mm, which gave 0.64 as the diameter, 1 over diameter. And the capillary constant can be determined through that. The unit of the capillary constant would just be the unit of the height divided by the unit of 1 over diameter, which would be, yeah, this. Question 4. Giant redwood trees can grow to around 100 meters in height. From this experiment, we can conclude that capillary actions are not the only mechanism used to move water through tree trunks. Use data from the image below to suggest how this experiment supports this conclusion. Height is basically inversely proportional to diameter, which is what we determined previously. So for a tree of this height, the diameter of the capillary tubes inside would have to be extremely small for it to grow to the extent it does through capillary action alone. And finally, the big investigation question. You decide to extend the experiment and investigate how temperature of the water affects the height that the water rises up the tube. Design an investigation that you could use to carry out this investigation. In your plan, you must include a research question, independent, dependent, one control variable. Unless they specify otherwise, you should be including 2 control variables, the equipment you need and how it will be used, the equipment to change the independent variable, measure the dependent variable, and keep the constant variables constant, your method for manipulating the variables, and how you will collect sufficient data. So this actually makes it easy for us because they show the procedure and how the experiment works through changing the diameter. So the only thing we're changing now is the temperature, but the major procedures are the same. So we know how the experiment works. So it's sort of easier to write. So research question, what is the relationship between independent variable and dependent variable? Independent variable, you mention what it is, temperature. How will you vary it? So we'll be placing the Petri dish with water inside a water bath, allow a constant temperature to be maintained. You can do it in any way, but usually temperature, the easiest way is to just mention a water bath. And you should include at least 5 increments for the independent variable with regular intervals. Dependent variable, the height that the water rises up a tube. So it'll be measured using a ruler in mm. You must always mention a measuring equipment that you'll be using to change the independent variable and measure the dependent variable. So you're changing the IV using a water bath, you're measuring the dV using a ruler. So the height will be measured from the surface of the water in the Petri dish. It's how you measure it. Constant variables, the diameter. So it'll be kept constant at this, measured with a ruler. So you mentioned what's the constant variable and how it'll be kept constant. So I included 3 just to be on the safe side, but they mentioned 1. But the thing is, if by chance that one constant variables you include is wrong, then you'll lose that mark. So just to be on the safer side, it's best to include more. Equipment required, you can sort of just put everything together. And how to collect sufficient data. I mentioned this in the science video. It's always at least 5 increments, 3 trials and an average in order to minimize random errors. And usage of measuring tools like measuring cylinder, water bath, stopwatch to allow accurate measurements to be made. Procedures are quite simple. So you measure water using a measuring cylinder. Whenever you measure anything, you always mention which measuring equipment you use. You pour it in a petri dish. You place it inside a water bath heated to 0 degrees Celsius. This doesn't really make sense in real life, but it's easier to write down as a procedure, so it doesn't really matter to that extent. Wait for 1 minute, measure the stopwatch to ensure that every portion of the water has consistent temperature. Then you place a 2.4 mm diameter capillary tube straight inside the water. One good thing about the way IB structures their questions is that they tell you before that the diameter was changed. Now they ask you to change the temperature. So you already have a very good constant variable that is guaranteed to be correct because you know for a fact that it'll impact the height at which the water rises. So measure the height that the water rises using a ruler and repeat the steps. Repeat step 4 2 more times to get an average. And step 7 should be down here. Repeat step 1 to 6 with a water bath for all the other increments in the independent variable. That's generally how you should write it. You don't necessarily have to write your procedures like step by step. You can write it as a paragraph. But for me, I think it's easier to organize and easier for the examiner to see as well if I write it in procedure format. Finally, criterion BC is completed. We're going to the final criterion D section. So one strategy used by infrastructure planners to transport people quickly in urban areas is the magnetic levitation train. This type of train moves using powerful electromagnets instead of the conventional rail and wheel system. This question had a few options and the type of metals that you could choose. So the metal that subtracted the magnets was iron out of the options. Maglev trains use repelling forces between strong electromagnets attached to the tracks and the underside of the train. These electromagnets lift the whole train to float at about 1 centimeter above the tracks. The train can travel at an average speed of 430 kilometers per hour. So there are three main systems in a maglev train that allows the magnetic forces to be used to allow the train to work. So they already give you the different system and they tell you how it works: levitation system, guidance system, and propulsion system. So the next question is focused on this. They ask you to identify the force corresponding to each system in the diagram below. So from the description that they give you, you can already tell which is which. Levitation system allows the train to stay suspended, so it must be this one. And propulsion system allows the train to move forward, so it has to be a backward force for the train to move forward. And finally, the only one left really is the guidance system that keeps the train centered over the track. So you can see it's maintaining that space here. Just process of elimination can help you determine which goes where. And compared to a conventional train with wheels in contact with the track, the frictional forces in maglev trains are lower. Suggest 2 advantages of lower frictional force. So one thing, obviously, there's less work done by the frictional force, so less energy is consumed for the trains to operate. And another advantage is how the lower frictional force allows the train to move at a faster speed due to the lower drag force. And the size of the repelling force depends on the distance between the magnets. The graph below shows how the repelling force varies when the distance between the magnets increase. A graph showing the magnetic repelling force against distance between the train and the track. We can see that as the distance between the magnets increase, the repelling force decreases. So they tell you to use the graph to explain the effect on the repelling force of an increase in the number of passengers. So when the number of passengers increase, obviously the total weight on the maglev train would increase. So this increase in weight would cause the maglev train to be slightly pushed down, which decreases the distance between the magnets. So, and according to the graph, we can see that as the distance increases, the magnetic repelling force will decrease. So when the distance decreases due to the increasing number of passengers, the repelling force would increase. This allows the distance between the magnets to be maintained for the maglev train to operate, even upon a greater number of passengers boarding. And finally, the big criterion D essay question. The increase in world population has created a need for a complex and varied transportation infrastructure. New technologies have given people the choice of several options for moving between cities. More people are able to travel long distances for work and leisure. People value comfort, reduced travel times, and low cost. The infographic shows some information related to 4 transport options that could be taken when traveling between 2 cities. So they give you 4 options to choose from: car, train, air, and coach. As you click each of the options, they give you sort of a description of the features of that transportation in terms of travel time, cost, comfort, travel time, reliability, and environmental impact. So that's for air. This one is for a car. This one is for a train. And finally, for the coach. So the question says that using information from the infographic above and your wider MYP studies, choose one of the alternative transportation methods. Discuss and evaluate your chosen method compared to a car. In your answer, you should include economics advantages and disadvantages compared to driving a car, environmental advantages and disadvantages compared to driving, the comfort of your chosen method, safety, and final recommendation. So you only choose one, you only discuss one of the transportations, and you compare it to driving a car, and you sort of give a final appraisal because they're using the command term evaluate, which means you consider strengths, weaknesses, and give a final appraisal. But you must be sure to include all of the points they mentioned in order to award you all the marks. So it's easy to organize your answer and for the examiner to see your answer if each point is organized in one paragraph. So economic advantages and disadvantages, 1 paragraph. Environmental advantages and disadvantages, 1 paragraph. Comfort 1, safety 1, final recommendation 1. So they can clearly see all your points. Because your examiners are human in the end, they may miss any points that you make if it's all in one whole bulk of a paragraph. So this is the answer I gave. The transportation that I chose, I think it's down here. Yes, I chose a train as the transportation that I want to compare to driving a car. So I start off with the economic applications. When you do this, you also have to make sure you use piece of evidence from the infographic because that's the reason they provided to you. Honestly, it would be harder to think without the infographic. So one way or the other, you would be using the evidence that they give you. So I start off with the economic applications. I start off with the benefits. I say that there's no need for maintenance and compared to a car. So that's my advantage, my economic advantage. Then I move on to mentioning the economic disadvantage, which I use based off of the evidence provided in the infographic. So I use actual cost of riding a train and buying a car. So I consider that when I talk about the disadvantage. So the economic side is covered here. Next would be the environmental side. So there are certain implications. Start off again with the benefits of a train in that it emits less carbon dioxide. So you have to make sure to explain your points, sort of show a bigger picture on why it's a negative or positive implication. And then I also mentioned an advantage, a disadvantage, environmental disadvantage to consider both sides. So now we already cover 2 points that the question asks for. And here I'm talking about comfort. You can see here that I only talk about the positive comfort that trains provide. So I never mention any disadvantages in terms of comfort because the question didn't specify it. If the question doesn't specify it, you can talk about both advantages and disadvantages, or only advantages and only disadvantages. If you have any ideas, it's best to talk about both. But otherwise, it won't lose you any marks because the question itself does not specify it. And here I'm talking about safety implications. There was no need for me to include both advantages and disadvantages, but I made sure to include both because I had a point for both. Thus, going back here, you can see that comfort of your children's car compared to driving. They don't specify whether it has to be in a better or worse way. The same for safety. And finally, you talk about conclusions in which you summarize the advantages of using your chosen transportation, which is a train in this case, as well as the disadvantages and what's your recommendation. So the recommendation that I gave is that the best recommendation would be to use trains for long travels while opting for cars for shorter travels because they both have their own respective advantages and disadvantages. So it's sort of an appraisal of the entire evaluation done so far. And that's the entire physics e-assessment paper, criterion A, B, C, D. I hope it helped you understand to an extent on how to answer different types of questions. Thank you for watching.